Hello, welcome back to class. Um, Today we'll be talking about Internet of Things, security threats, and then solution in the AI age. The security threats and solutions in the AI age as it pertains to Internet of Things. And we'll be looking at the Internet of Things security fundamentals. We're also looking to common Internet of Things threats and vulnerabilities. We'll look at data privacy and protection. Also, we'll look at the AI-driven cyber threats. We'll look at security framework and solutions. And lastly, we'll look at the legal and ethical issues in um, Internet of Things security. Now, the proliferation of Internet of Things devices across industries, homes, and cities has created a vast interconnected ecosystem that generates immense value and also significant risk. And as AI integrates with Internet of Things to enable autonomy and intelligence, the attack surface expands and introducing new vulnerabilities and sophisticated threats. And that is why we need to look at it as a model to look into the fundamentals of the Internet of Things security, the common and emerging threats, and also the framework and solutions needed to be able to protect connected systems in an AI-driven age, and why this matters. Why can we say this actually matters? We've seen that billions of Internet of Things devices collects sensitive data and controls critical infrastructures, and AI can both defend and attack, creating a dual-use landscape. And the security is no longer optional; it's foundational to trust, safety, and compliance. And that is why you need to understand this to be able to gain a comprehensive understanding of how to secure Internet of Things ecosystem against evolving threats, ensuring reliance, resilience, privacy, and also ethical integrity. Looking at Internet of Things security fundamentals, we have the core principle. And these are the confidentiality, integrity, availability, authentication, and authorization. Talking about confidentiality, this is actually the ensuring that data is accessible only to authorized entity. Also, as per the integrity, which is another core principle, it deals with protecting data from unauthorized alteration or corruption. Another is the availability, which is it must ensure system and data are accessible when needed. And also, as per authentication, is a core principle, and there is need for verifying the identity of users, device, and application. Lastly, authorization as a core principle is there is need for defining what authenticated entity are allowed to do. And we have the unique Internet of Things security challenges. This is in terms of device heterogeneity, talking about diverse hardware, different operating system, protocols, and life cycle. Another is the resource constraint in terms of limited CPU, memory, battery, which hinders traditional security measures. Another constraint is the scale and complexity, that is managing millions of devices across distributed network. Another is the lifespan and maintenance, which deals with many devices which are deployed for years without update. And lastly, which are under the challenge, is the physical exposure, that is devices in uncontrolled environment are susceptible to tampering. And why security is non-negotiable? First is that prevents unauthorized control. It also protects sensitive data, and it also maintains operational continuity and public trust. We have common Internet of Things threat and vulnerability, and let's talk about the common threat first. The first one is the malware and ransomware, and this affects infect devices to steal data, disrupt operation, and also demand ransom. Another is the botnet, and it's a compromised Internet of Things device used in large-scale DDoS attack. We also have the man in the middle, and this is an interception and manipulation of data in transit. There is also the unauthorized access, dealing with weak authentication, which leads to device takeover. We also have the data breaches, um, talking about exposure of personal, operational, and proprietary data. And lastly, under common threat is the physical attack. And this deals with tampering, extraction, or destruction of device. And for vulnerability, it can be seen in terms of default or weak credentials, unpatched firmware, that is outdated software with known exploits. Another is insecure communication, that is lack of encryption, and another is poor network segmentation, and lastly is insufficient logging and monitoring, that is inability to be able to detect anomalies. Looking at data privacy and protection in Internet of Things, why does data privacy actually matters in Internet of Things? Internet of Things device collects highly personal data. It locates data like location, health metrics, daily habit, voice recording, and more. And breaches can lead to identify threats, surveillance, discrimination, and also loss of autonomy. And key principle under this is data minimization. That is, you have to collect only what is necessary. There is no need to collect everything. It's just to collect what is necessary. And also is purpose limitation, which is another key principle. That is there is a need for the use of data only for stated legitimate purpose. Another is user consent and transparency, which deals with need to inform users and also obtain explicit consent. And lastly is data ownership and control, and this deals with users should be able to manage their data. We have protection technique. If you have to protect data, how can we do that? The first one is encryption, and when we talk about encryption, it's actually an end-to-end encryption for data at rest or in transit. And we also have another technique as access control, which perform a role-based permission and least privilege access. Another technique is the anonymization and pseudonymization, that is remove or mask identifiers. Another technique is the regular audit. That is, you need to monitor data access, usage, and compliance. And the last technique for protection of data is this secure data lifecycle management, which is from collection to deletion. And we have relevant regulatory landscape, which is the GDPR for the European Union. We have the HIPAA for US healthcare. There is the CCPA or CPRA for California. We have emerging global laws like that of the Brazil's LGPD, Indian's PD, PB, and the likes as such. Let's go to AI-driven cyber threat in Internet of Things. And for this, AI enhances Internet of Things with intelligence and automation, but also equips attackers with adaptive, evasive, and also scalable tools. And we have the types of AI-driven threats, which is the first is adversarial attack, that is manipulating sensors input or data stream to full AI model. And another is data poisoning, that is corrupting training data set to degrade AI performance or introduce biases. And also we have the autonomous malware, which deals with AI-powered malware that learns system behavior to evade detection. And another type is the AI enhanced botnet. And this is a smart bot that identify vulnerability and coordinate attacks autonomously. And the last one is deepfake and spawning, deepfake and spoofing attack, that is the using of AI to mimic voice or faces for biometric um, bypass. And the implication of this is that it undermines trust in autonomous system, it increases difficulty of detection, and lastly, it amplifies impacts. For security framework and standard for Internet of Things, um, they actually provide structured, repeatable approach to security, essential for consistency, compliance, and also resilience. And the key framework are the NIST Cybersecurity Framework, which identify, protect, detect, respond, recover, and also is widely adopted for risk management. We have the ISO, um, we have the Internet of Things Security Foundation framework. Also, there is also the Industrial Internet of Things Security uh, framework. We also have the OWASP Internet of Things Top 10 also. And we have the implementation layer. And the first is device level, which talks about secure boot, hardware root of trust, and temper resistance. We also have the network level, we have the cloud or edge level, and we have the application level. In conclusion, we've been able to look at the core principles that are necessary when we talk about um, data security. We've looked at common threats and the vulnerability also. We've seen data privacy, and we've been able to look at some frameworks. And in the AI age, Internet of Things security is not just a technical challenge. It is a strategic imperative that blends technology, policy, ethics, and continuous adaptation. Thank you for listening.